Our next speaker is Gabriel Durkin. He's a data scientist and quantum physicist and has an extensive track record directing data science research in organizations like NASA, Uber, and Foursquare, three of my favorites. So really looking forward to you sharing the app that you've built and the training for ML models using Streamlit and Fused. And yeah, we'll hand it over and let you get rolling.
So yes, as a data scientist working with geospatial data, I've had some exposure to Fused over the past few months, and I realized that there are so many different assets in Fused. There's Sentinel-2 multispectral 13 bands of data that you can access through a Fused Sentinel-2 Explorer UDF. I actually built one for Sentinel-1. We have the Cropland data layer for the United States, and we have elevation models. There is land use, land cover data. So, when we're talking about building ML models are really obviously just a representation of the data that they're trained on. And, in an ideal world, I imagine we're going to be like Tom Cruise in Minority Report. We're going to be able to pool resources from the left and resources from the right. And in machine learning, one set of resources will be your input, and another one could be your target or your output. And so I wanted to build an app that kind of abstracts away a lot of that kind of engineering, even the UDF construction, the user-defined functions infused. I wanted to abstract that away so that, for a data scientist who wants to build a machine learning data set for a particular type of capability, that they can do that kind of on the fly in this kind of Minority Report way. So I I was playing around with the Fused app builder platform, and I built this kind of slightly janky prototype app here. You can see it's called Geosynth. And so this was what I came up with, just in the past couple of weeks now. 3 weeks ago, I've never touched Streamlit before or worked in the Fused app platform. So if I can do this in a couple of weeks, I'm sure most of you could too. So what have I done? So I'm really just trying to do the same thing I described. I've got Fused assets on the left side of the screen and a different Fused asset on the right. And, I want to build a machine learning data set or a set of chips out of this data, right? So on the left side here, for instance, we have Sentinel-1 data, and on the right is Sentinel-2. And, this being kind of like your ability to build a data cube. I've drawn some cubes on the map already, you can see. So in this case, you would have Sentinel-1 as your input on the left there, and then Sentinel-2 might be your output. So this could be a task of, sensor translation. And then, depending on the task you're interested in, you want to maybe explore a particular region of interest on the map. There's the capability here of drawing polygons, and then this Fused Geosynth app will package all of the tiles that are overlapping with the polygons you draw. And then, you can send those data sets to Hugging Face, or you can store them inside Fused in Fused File Explorer. But then you're basically ready to go and build a model. So there's lots of knobs and bells and whistles. And so one that I want to draw your attention to is this time slice aggregation. So in this case, the right side map, I'm trying to show the three. So we're looking at data for a particular survey period. So this is the year's 2022. We're looking at data for October. It's San Francisco, obviously. But this time slice aggregation we're showing is like, this slider shows like the X least cloudy images from that month, and then it does an aggregation over them. So now we're looking at the three least cloudy images from Sentinel-2. It's three particular bands. I'll show you which ones. It's a glacier index, band 8 and band 11. That's what's giving this this kind of crazy red color to the map. So that's it. And like I said, you have this tileify button, then that will create the tiles, and then you can export the tiles that you create and store them locally, or stream them to Hugging Face. Okay, so let's quickly go somewhere else. Let's go to like Manhattan. And so this is the same thing again. I guess I've already drawn some polygons on the map in Manhattan. And then, you know, once you've, so let me just erase those, reset drawing. Just to demonstrate like how it works live, we can just select an area of Manhattan, maybe somewhere downtown. Let's see. And then when we hit Tileify, you know, there will be some tiles generated from that polygon that I just drew. Then the next step is, you know, we're going to call this tiles demo 2. You can export the tiles and they'll be stored locally. Rather, it's the instructions associated with those tiles. So when you create the actual tiles later on as a batch job in fuse.py, all of the metadata, the tile boundaries, all of the metadata here, the thresholds that you set, the time period, all of that will be stored in the geodata frame and stored as a Parquet file locally. Okay, and so let me just show one other example. I'll go somewhere else. Let's take you on a tour of 3 or 4 different places. I wanted to look at Truckee, which is a town that sort of sits between California and Nevada, but is pretty high up in the mountains. So if we, instead of looking at Sentinel-1 data, you know, we can look at a different resource. We can look at the digital elevation model. We can choose a different color map, twilight, let's say. And then it's just a way to visualize, like, is this going to be a useful feature for, you know, building a machine learning model? So right now, this is just elevation. We can look at the magnitude of the gradient. Let's see if that's going to show.
Would it be possible to also take a look at the model results real quick before we have to?
Yeah, absolutely. Yeah, that's the next thing. So what I'm trying to show now is just that, you know, all of these fused resources are here. This is the magnitude of the gradient of the elevation. For instance, if I wanted to look at, you know, let's say predicting where grapes are in California, grapes tend to sit on a shallow incline, like 10 or 15 degrees. So that could actually be an informative feature if you were building a model for detecting where vineyards are. Okay, so, you know, I previously, since machine learning is a bit like baking, and if this was a baking show, we would talk about one that we built earlier. So let me go just to one last place. I want to go to Jacksonville, where I've never been. There's a few different Jacksonvilles in America, but the one I want to go to is in Illinois. And so, yes, previously I built a model on 10,000 of these tiles that I've been showing. And the objective there was the cropland data layer. And so if we switch to the cropland data layer, this app is not just for the purposes of, you know, curating these data sets. It's also for inspecting the model you produce. So I have this mask-to-former model, which actually is trying to reproduce the cropland data layer as ground truth. So you can see the interesting thing, actually, one of the interesting things is that the cropland data layer itself is a 30 by 30 meter resolution, but the outputs of the model are actually predicting, that's on the right side of this swipe bar, are predicting at 10 meters. So it actually has the effect of kind of creating a super resolution in the output of the cropland data layer. And so one thing I didn't talk about was you can do spot analytics on the left and the right side of the map. If it's RGB, you'll see these analytics in terms of, you know, those 3 channels. But if it's, you know, if it's like this, if it's discrete classes, then you get discrete bars associated with the classes that you're seeing. And then the last thing you can do is you can actually evaluate the performance of the model against, so this is taking a snapshot of the center of the map, and whatever data is there, it's comparing the cropland data layer with the output of the mask-to-former, which is the transformer model I'm using to make the predictions about the different types of crop. And so you can
Very
see,
cool.
yeah, so there's the intersection over union of the 9 crops. There's 3 of them absent from the current image. That's why those are blank. But you can see it's actually doing a pretty good job with corn and soybeans, getting up to 70, 80% intersection of reunion. So that's
Yeah.
it.